Let me introduce our topic for the day. Welcome to another Lab Date Live with WHSTEP. And today we have Dr. Rachael Treharne from the Woodwell, I hope I said that right, from the Woodwell Climate Research Center, talking about Arctic change, how much, how fast, and how scary, kind of a contemporary topic. Rachael, thank you very much for coming in.
Great, no worries, and thanks so much for having me here. I'm really excited to be speaking to all of you logging in today, even though we can't be here in person. It's great to speak to you all. So I will start sharing my screen, and hopefully everything works because my computer crashed 2 minutes before I was trying to log in. So hopefully everything's come back okay. But yes, so as I've just been introduced, my name is Rachael, and I'm a scientist. I'm a postdoctoral researcher at Woodwell Climate in Woods Hole. And so I'd like to start by acknowledging that Woodwell Climate Research Center is located on the traditional and sacred land of the Wampanoag people who still occupy this land, and whose history, language, traditional ways of life and culture continue to influence this vibrant community. I'm going to be talking to you today about the Arctic and about climate change. But first, I would really like to ask all of you out there a question. And so I'm going to do the worst thing you can possibly do with an online talk. And I'm going to try a new platform that I've not used before. And so if you're able to, if you've got a phone or a laptop handy, maybe you could have a go at going to this website, just menti.com, and you should there be able to put in this code here in yellow, and you should be able to put in your answer to this question, and I should be able to see those popping up over here. And the question I'd like to ask you all, and this is just purely for my interest, is what is it that you first think of automatically when you hear the word Arctic? What's the first thing that pops into your head? So I'll let you keep putting your answers in there for a moment. And I'm going to tell you a bit more about what one of my answers to that question is, and that really is change. The change that we're seeing happening in the Arctic is really immense. We're talking really about almost sort of geological scale change happening in human lifetimes. And I know the Arctic, for many of us, it can feel quite remote. Of course, it is quite remote. And it can feel quite detached and far away for those of us who are a long way from the Arctic, sort of sitting here in front of our computer screens. But despite that, this change that's happening in this part of the world is something that is already affecting all of us around the world. It's something that is already affecting you and I. And so I do want to give you a little bit of a flavour of what that change means and what it looks like, and of course why it's something that all of us should be aware of. But I wanted to kick off with a little bit of context. And to start right at the beginning, really, we have this question: what actually is the Arctic? And it sounds a little bit obvious, but actually there is no single correct answer to this question. So I've asked people this in the past, and people have talked about the Arctic Circle, talk about temperature, and talk about the presence or absence of trees. And all of these things are sort of ideas that we can turn into valid definitions of the Arctic. But for me and for lots of us as scientists who work on the sort of scale of ecosystems, often we define the Arctic as the area kind of covering these two different biomes. And the first of those is the tundra. And that's the area you can see on this map here. That dark ring there is the Arctic Circle. And the darkest shading is that tundra biome. And the tundra is this really quite sort of classic Arctic landscape. This quite open landscape. You can see in that top picture there's all these little small shrubs. And then the bottom picture, we've got more sort of grassy landscape with these little tufts of sedge, and we call this tussock tundra. The tundra also includes some sort of slightly different landscapes. This is polar desert, this is in Greenland. And you can see that this does looks quite harsh, it looks quite bleak. There is still life going on there, but we still have all these little mosses and lichens and other plants going on there. But again, quite a sort of, possibly quite a classic Arctic, what we might imagine as an Arctic landscape. The second biome is the boreal forest. And this is that lighter grey area on the map here. And this is a band of coniferous forest that, as you can see, it goes almost all the way around the globe. And that could be, like you can see in this bottom here, it can be quite sort of open forest, almost looks a little bit scraggly in this picture here. This is taken up in northern Canada. But it can also be more what you imagine, that really sort of thick, dark, dense coniferous forest. And within both of these biomes, of course, there is a lot of diversity within those broad categories as well. I'm kind of conscious I'm showing you these pictures of these very sort of flat, continuous landscapes. But of course, the Arctic has mountainous areas, it has wetlands, it has the full diversity of landforms. And the Arctic also has a lot more diversity than often I think we give it credit for in other ways as well. So it has a lot of really fantastic wildlife. We always talk about polar bears, it's not just polar bears. So here we've got some bison who made it quite clear we weren't going to be making it onto our field site that day, again in northern Canada. We've got a black bear skull, we've got this little lemming, this is up in northern Norway. And that last picture there is a blue whale just off Ny-Ålesund in Svalbard in the European Arctic. But really, for me, my favorite part of the Arctic is the plants. And often this is a bit of a hard sell, but I think it's fair to say that plants in the Arctic are one of the most hardcore group of things on the face of the planet. This, you have to remember, this is an environment which in the winter is dark 24 hours a day. It's really cold, often there's lots of snow, lots of ice. And then in the summer, we have that much greater variability in temperature. We have daylight 24 hours a day. Often we have fires. It's a really extreme environment for these little things that can't move, and they just power through all of that. And some of the ways that they do power through that, I think, are really fascinating. The Arctic, for example, is one of the only places on Earth where you'll find plants huddling together to keep warm, which I think is quite incredible. One more thing, just something which I find sometimes surprises people about the Arctic is something that's a little bit less fun. It also has a lot of bugs, and specifically a lot of bugs that are going to bite you. So this is, again, a mosquito up in Svalbard and a cloud of horseflies we had to fight our way through to get back into the car at the end of a day of field work at one point. Another key characteristic of the Arctic is, of course, that it is, as I mentioned with the plants, it is an extreme environment. And one of the ways that it's extreme is also the sheer rate at which it's heating up. All of us know, I think, that climate change means that global average temperature is increasing. But you can see this, so this image here is showing projected temperature change by the middle of this century, so in about 30 years' time. And it's showing that as elevation. And I think it shows really clearly, this is a map produced by Greg Fisk at Woodwell, and it shows really clearly that disproportionate rate of warming that the Arctic is experiencing compared to the rest of the world. It's really quite striking. And this pace of warming, it's something that, you know, it's not just numbers on a screen, it's something that is very tangible and we can actually see quite easily. So these pictures here, these was just shared on Twitter by another scientist whose Twitter handle is there. And what you can see here is a field site that he set up in 2015. You can see he sort of set up those boardwalks to be able to travel around the site. And what's happened here is that as temperatures increase, this area has warmed, the soil has warmed, it's begun to thaw. And that means that it's collapsed in on itself. And you can see that really in just a handful of summers, this whole landscape has become this whole new wetland feature that wasn't there before. So we come, of course, to the question, why do we particularly care about this? The Arctic, for a lot of us, is a long way away, and we know there are a lot of other ecosystems around the world which are also experiencing really severe impacts of climate change. So why the Arctic? First and foremost, one of the reasons for that is that the Arctic is very much not the uninhabited region that often we think of it as. It's home to more than 4 million people across the Arctic. And this is a big area, so it's a relatively sort of sparse level of population, but nonetheless, these are human communities, and these are human communities who usually have contributed almost nothing to climate change, but nonetheless are at the front line of vulnerability to its impacts. And just to highlight that really, This quote is from a resident of a village in Alaska, and they say, "Every building you see in the village is slanted or warped. We might level it up, but by the next spring it's slanted again. There is no hard ground." And again, what they're highlighting here is that same process that you saw in those pictures earlier. So as the Arctic warms, the frozen part of the ground, it thaws, it becomes soft and unstable. And you can imagine the impact this has on people's houses, on your ability to travel around, all that sort of normal infrastructure you need to live your everyday life. And you can see that in this picture here. So this is someone's house, and it's been affected by that softening of the ground. And it's also been affected by an unseasonal storm, and that's resulted in this flooding here. But there's another reason that we should care about what's happening in the Arctic, and that is that what happens in the Arctic just doesn't stay in the Arctic. And there's a few reasons for that. One of them is another core characteristic of the Arctic, and this is that it is a vast reservoir of carbon. So if this little bubble here represents all the carbon that we know is stored in the atmosphere, then this is how much is found in Arctic soils. So it's almost twice as much as is in the atmosphere. It's almost 3 times as much as is found in every tree across the face of the planet. So this is a lot of carbon. And the reason for this is it's pretty simple, really. It's linked to, well, it's because it's cold. And you can imagine why this is the case. If you just sort of think about something like having a compost heap in your garden, you know, if you have some vegetable peelings, you take them out to your compost heap, you know, they're going to rot down, they're going to decompose. And if you do that in the summer, you know, they're going to rot down much quicker than if you go out in the winter and it's all cold and frosty. You know, those vegetable peelings are probably just going to be sort of sat there the next time you go out. They decompose much more slowly. And that's what happens in the Arctic. We see that sort of dead plant material, instead of rotting down, accumulating into these really deep, rich soils, like you can see here. You can see really this is all plant matter, all this whole profile. So, and as this plant matter and all this really rich carbon-rich material builds up, it is gradually incorporated into the frozen part of the soil, and that is what we call the permafrost. That's soils which are frozen for at least a few years permanently. And of course, the importance of cold temperatures in this process means that all of that carbon locked up in these cold soils and these frozen soils is put under threat as the Arctic heats up. And one of the ways that happens is that the permafrost, that frozen part of the soil, begins to thaw. So we see permafrost thawing in more than one way. So we see this kind of gradual thaw happening slowly over time from the top down. But we also see this quite dramatic process where we have abrupt thaw. So in areas where perhaps there's lots of ice in the soil, and that thaws, and we see this sort of large-scale landscape collapse, these quite dramatic features. And sometimes these can become lakes, or they can sort of present in lots of different ways. But there are also other ways that all this carbon in the Arctic is being threatened. And one of those is actually by fire. So sometimes it can seem a little bit odd, but these areas do burn. The boreal forest burns, and the tundra in particular, as these areas warm up, is burning more often over larger areas and with greater severity. And that's partly because of the warming that we're seeing happening. It's also because of other things like the fact the Arctic is becoming stormier. Often it's lightning strikes that start these fires. And something particularly, I think, interesting and also concerning that we're seeing happening is actually what we call zombie fires. And zombie fires are fires that get burned deep down into that thick layer of plant matter, like in that picture we looked at earlier, and they can smolder away there, and with so much fuel and sort of deep under the ground, that they're able to actually keep smoldering away and keep going over the winter. And then come spring and come summer, when the snow melts away and temperatures increase again, those fires are actually able to keep going, come back up to the surface, and even start spreading again. And and of course, when we have those fires and we have these areas burning, that of course then has a knock-on effect on exacerbating that permafrost thaw as well. And the concern here is, of course, that all of these things are releasing some of that locked away carbon back into the atmosphere. But it's also that in doing that, we are sort of initiating what we call a positive feedback loop. So we see the Arctic warming up, we see all those processes we've just talked about happening, releasing carbon into the atmosphere. And this, of course, accelerates climate change. And this, of course, warms the Arctic. And we enter this sort of vicious cycle, a self-reinforcing feedback loop. And you can imagine at this point that the implications of this are significant. As scientists talking about this kind of thing, obviously this has an impact on what we want politicians to do. It has an impact on how we think about our future. And so at this point, I think it's quite reasonable for us to sort of want to take a step back and say, okay, well, how do we know this? Where does this knowledge come from? How confident are we in these things? And so I wanted to just give a very sort of skeleton answer to that question. I'm happy to chat more about any of this. But the skeleton of the answer to that question is data. So this picture on the left here, this is a couple of my old colleagues drilling permafrost cores. So what they're doing here is really collecting data in the field in the form of sort of real physical samples that then will go back to the lab for analysis. But we can collect data in other ways. So this picture here at the top, this is an experiment being done out in the field, looking at extreme periods of warmth during the winter. But we might also use data that we haven't physically collected ourselves. We might use data that comes from satellites, for example. We might use existing data products that have already been made by other people. So this image here in the bottom right, this is a data product that can actually tell you the elevation of the Arctic at any point in this image. So once we have our data, the next step is to analyze that. So by analyze it, I mean, we take all that data and we look for patterns or trends or any kind of relationship between sort of different things that we've measured. And once we have that analysis, the next step is then to take that back to the questions that you initially wanted to ask and say, well, have we answered that question? How much have we answered that question? And then to sort of write up those conclusions and to publish that in a scientific journal. So once you get to that point, you've published in a scientific journal, you've basically produced this little nugget of knowledge that's been reviewed by other scientists, and it's been put out into the scientific community for other people to sort of look at, and try and replicate or act on with their research. And through that process, over time, that's how we eventually end up with these big sort of synthesis efforts. So reports by people like the Intergovernmental Panel on Climate Change. And these are the kind of reports that maybe you've heard about in the news, talking about sort of consensus among scientists. So it's the kind of end result of all these little pieces of knowledge that we produce as scientists. So that's a super introductory picture of where that knowledge comes from, like what is it? But what does our existing knowledge then tell us about the question we asked at the beginning of this presentation? So Arctic change, how big, how fast, how scary for the rest of the whole planet? And I'm going to dodge the question a little bit, I'm afraid, because we do need a lot more knowledge before we can give a really clear answer to that question. But we do have some data, we do have some of those little nuggets of knowledge, so we can make some informed kind of predictions or guesses. So to look at that, let's imagine this box here is our carbon budget to remain within 1.5 degrees of warming. So by that I mean this is the amount of carbon that we can put into the atmosphere before we exceed 1.5 degrees of warming. So we're at 1 degree of warming at the moment. So the Arctic and all the carbon stored in it aren't already factored into this budget, because we just typically don't do that because we don't have enough knowledge, unfortunately. But according to some of those bits of knowledge that we do have, this is how much gradual thawing of the permafrost could reduce that budget by. This doesn't factor in that kind of abrupt thaw, that sort of landscape level collapse that we looked at. So that process could reduce it by a further amount. That's something like this. And then we move on to some of those other processes. We think about fire, we think about the impacts that fire has on the permafrost. And this is where it becomes even more difficult to really make those estimates. And this is actually something that I and colleagues at Woodwell Climate are working on a bit more at the moment. But so from my point of view, a sort of fairly conservative guess might be something like this. So you can see we've really reduced this budget by quite a lot already. And for context, at the moment, this is what 1 year of global emissions looks like. So you can see that it's really becomes, when we factor these things in, quite challenging to keep within that budget unless we make quite a lot of quite drastic changes. So what does this mean? For the Arctic, of course, it means even more change is coming. And it means really that the Arctic, as we imagine it, is an Arctic that it will be hard for many of us to experience, because in the future, it's less likely that the Arctic will be that place. And I think it's put quite well by this journalist who says the Arctic of the past is already gone. Following our current climate trajectory, it will be impossible to return to the conditions we saw just 3 decades ago. And others have been even more blunt. The Economist have referred to the Arctic as dead habitat walking. And of course, again, thinking of the residents of the Arctic, this can be really devastating. And this quote from Albertina Charles, an Arctic resident, reads, "If only there was no erosion, no flood, no permafrost melting, we would still be over there, but we'll get used to it." And what she's saying here, she is from a village in Alaska which has had to sort of be wholesale moved because of the effects of climate change. And I find this quote quite moving because I think it shows so much resilience. I think if I had no choice but to sort of uproot my whole life, leave somewhere where I've always lived, a place that I most likely still feel is my home, I think I'd struggle to say I'll get used to it. But of course, this also demonstrates the injustice of climate change that it's so important we're conscious of. These communities, these people who stand to lose the most, have contributed really nothing to the cause. For us as a global community, it also means more change. It means a changing world. So these are some of the impacts of a world warmed by more than 1.5 degrees, highlighted by the Intergovernmental Panel on Climate Change, that sort of synthesis effort of science I mentioned earlier. And some of the things they mention here are things like increasing water stress, pressure on food prices, more food insecurity, hunger, poverty, forced displacement, so people being forced to leave their homes, loss of identity, and reversing progress that we've made in sustainable development and human security. So I know that at this point, some of this stuff, this is quite heavy. Some of these impacts are quite severe. But I do want to share this science with you because it's important. But of course, when we sort of talk about this stuff, the next step is to say, well, okay, that's all well and good, but what do we do with this information? And often at this point, when I talk to people about climate change, about what we're seeing in the Arctic, I get this question in various forms. Is it too late? Is it too late to save the world? Is it too late to stop this? And I understand why people ask this question, but I think really it is the wrong question. What does too late mean? What does this mean? And I think really the question that we should be answering is actually this question. Whatever happens, how can we get to the best future that is available? How can we minimize the damage that has already been done and will be done? And the good part about this question is that there are really a lot of answers. There are so many things we can do that, regardless of the situation we're in and regardless of the implications of that we can still improve things and make things better. So there are a lot of things that I'm sure all of us are aware of. There's renewable energy, There's investing in green jobs, reducing the power the fossil fuel industry has in politics. But there are others as well that we don't talk about so much. And as scientists, we should be more aware of. And I think one of those, just as an example, is educating and empowering women and girls around the world. This actually can have a really huge impact on climate change. And there's a number of reasons for that. But one of them is that empowered women who have access to education and access to more resources are able to make their own choices about when and if and how often they want to have children. And of course, this is something that has an impact on population growth, has an impact on demand for resources, but it's also something that we want to do anyway, right? This is something that is just the right thing to do and also has a really positive impact on climate change. And carrying on talking a little bit about solutions, I don't know how many of you out there might have heard of Project Drawdown, but it's a great project and they have a fantastic website that you can browse around and look at different solutions to climate change. And I wanted to highlight this. This is just a list of some that have a really big impact that I've taken off their website. And I wanted to mention it because I remember when I was younger thinking, okay, you know, I get it. This is a really serious problem, but what can I do with my life to try and help this? And that's part of the reason that I ended up going into research. But actually, what this highlights, I think, is that whatever you want to do with your life, whatever you find most exciting, there's a way for that to help with this problem. So you can see here that some of these solutions, these require everything from engineers to people working in finance to campaigners, people interested in health, in agriculture. We very much need everything and everyone with this to deal with this problem. And so I think with that, I will probably stop talking for a bit. And I'm really happy to, I know there's a few questions that have come in as people signed up anyway, but I'm really happy to chat about any of this, or if anybody wants to reach out and chat more about science or any of this later on offline, I'm really happy to do that as well. But for now, I will leave it at that and stop sharing my screen. Thanks so much for listening to me.